So as we wrap up chapter 11, we've got a couple sections left to go, and I think they're the most exciting parts, perhaps of the entire semester. Who knows? That using series to do things that we couldn't do with calculus is just a step up in our game. So in section 9, we're going to learn how to take a series that's a small little guy, and we're going to learn to tweak it and manipulate it using algebra, using calculus, and build other series from it. That's a big step. And it helps us when we learn how to do Taylor-Maclaurin series, we'll do the same thing with those, and then the sky's the limit. Anyway, decided to break this into two pieces, and they're probably going to break right here. This is going to be part A of the video thing, and this will be part B in terms of the lectures. Okay, so let's go here. A power series from a geometric series. All right, so what I did in lecture already, but we'll do it again, is show you guys that if you're looking at a geometric series, the story we know is that if I've got some number and then the next number I'm adding is the number times another number, and then you just, every term after that is just basically multiplying and multiplying and multiplying again, like you could have a 5 and then plus 5 halves and then plus 5 fourths and then plus etc. You realize that A1 is 5 and R in this case is 1/2. And we have some experience with that, right? We also know that the series, we'll write it in sigma notation, 0 to infinity, let's say, x to the n, oh, whoops, wrong thing, I'm getting ahead of myself, a sub 1 r to the n, converges to a1 over 1 minus r if the multiplier is less than 1 in terms of magnitude. Okay, so what I did in the lecture was, I'll do the same thing. What we do is we create a series that is a power series from this information we know. That is to say, what if we let a1 be 1 and we replace r with some variable x? What happens? Well, what we end up with is we're looking at a series n is equal to 0 to infinity. A1 is 1 and r is x, and we get the series, it says, n equals 0 to infinity, x to the n, and that's equal to 1 plus x squared plus x cubed plus, believe it or not, that is a geometric series, and it would converge just like this one did up here, but it would converge to, let's see, a1 is 1 over 1 minus the multiplier, which is a variable x, provided at the size or magnitude of your variable is less than 1. Now, listen, r can be anything you want it to be. You can build any geometric series you want. So x is just standing there as a placeholder. Whatever you want r to be, here you go. So it actually creates for us our first power series. So you want to write this down. In fact, I think I'll just leave what I've written alone. I'll just say, I'll tell you what, I'll highlight in another color. This is important to us, so we're going to go, this first guy right here is our first power series. Okay. So that's the story on this page, is basically we create a power series, and what I said in the lecture was true. I mean, certainly, if I wanted to compute with this guy, I could go, well, x is equal to 5, then I've got 1 over 1 minus 5 is negative 1/4, etc. So it's a useless thing, really, because in our series, all we can do is plug in any number between -1 and 1. But we could do it, okay? So that's not the point of this. The point of this is going a little bit farther with this. Hey, I've got a series that when I put numbers together, watch this. If I pick one that's from there, like say I plug x equals, well, I don't know, -1/2 in, well, the function tells us 1 over 1 minus a -1/2 is 1 over 1 plus a half, which of course is 3/2, so we end up with 2/3. What that's saying is if I used a multiplier here, that's what the function does. But If we use the series n is 0 to infinity, and we plug in minus 1/2 to the n as our variable, then what we get is 1 minus 1/2, right? Plus 1/4, minus 1/8, plus etc. And you know where this is heading? Eventually, 2/3, because that's what geometric series do. Okay. All right, so, you got the thing where you can plug in, and you got the other thing, the series, where you just put in a number and you add as many terms as you want. All right, that's cool. Now watch it in action with these 3 examples here. And I think that's then something about the interval, but I think that's going to be it for this video. So watch this. You ready? Okay, so this is more stuff that we do. Suppose I want to find a series for this particular function. F of x is 1 over 1 plus x squared. The first thing you learn to do is that you are allowed to do composition of functions to build new series. You ready to try? Let's do this thing. So we need a little dividing line here. I wish I'd put it in. Okay. What we do, though, and what I do in our lecture notes is I just recall to you guys, hey, I'm trying to build a series from this known series. And what I'm going to do is I'm going to put scribble in red there, because I'm saying you can plug anything in there. It'll go to 1 over 1 minus scribble, whatever you want to put there, and it'll converge provided absolute scribble is less than 1. Now, scribble, what I mean by that is anything that you decide to compose the function with. And this is really the template right here to follow. And it's how you do all the problems in this section. You're trying to get back to that series. In this one, it's not difficult. So I'm going to watch. We're going to make a function turn into a series. You ready? What I'll do is I'll write this function as 1 over 1 minus scribble, but it ain't scribble this time. What it is minus x squared. Now stare at that. That's true, isn't it? From algebra, that's true. But we have a series for 1 over 1 minus whatever. And that series, in terms of function notation, sigma notation, is this. It's whatever you put in there to the n power. And we put in minus x squared. Okay? So are we done? Well, we can clean it up. Watch how I do this. We can clean it up. We can simply go, hey man, I've got n from 0 to infinity. What I like to do is I split the negative out of there to the n power, and then I'll take care of the power of x by multiplying, a la algebra, the 2 powers together. And that's it. I've built a new series. But I want you to see something. This supplants going, I'm going to plug in 1 plus whatever squared plus, and in that case we put in scribble as well. In fact, you could put a note at the top that that's also what we do. In this case, it's minus x squared. So what I'm doing is I'm following this pattern right here. I'm going, whatever you put in right there, you put into the series here, here, here. There's the sum, provided, again, that thing is less than 1. That ought to be like tattooed on our memories or something. In fact, I'll put it down here. I'll put it down far enough so we can see it. So what we're saying is whenever we have 1 over 1 minus, whatever it is, and so you can put scribble. All right, I'll put scribble again if you insist. That is equal to summation. That's my worst sigma, right? Summation, still bad. N is 0 to infinity. This thing, whatever it is, plugged in, we're composing, or it's 1 plus whatever squared plus whatever. Okay, and those whatevers are whatever you decide to plug in there. And finally, you'd say it converges to that provided scribble is less than 1. Okay, so in this example, I'm doing that by just going, okay, I'm doing it 2 ways. I'm showing you the sigma notation, which is a fine answer there. But it also is good to see it written out as 1 minus x squared plus x to the 4th minus x to the 6th plus, and you can see it that way too. We're going to need both of these forms when we're doing our homework. One, when they say, hey, give me the answer in sigma notation. Okay, there it is, right there. But the other one is, hey, I want you to use the series to approximate something. And okay, we'll do that too. But before we get into that, that's going to be the next video. Let's do these two and wrap up with how to build these things. Okay, you ready for the next one? Here we go. Again, we're going for this form. So what we'll do, here's another thing you can do. See the 5x upstairs? That's bugging the heck out of me. Guess what I'm going to do? I'm going to write it as 5x times, guess what? 1 over 1. You ready? Minus, what do you think? How about a minus 4x? That work? Sure does for me. And what do you know? You got the series staring you in the face again. So we go, okay, what I've got is 5x times, this is new, series, n is 0 to infinity. And what is it that goes in there to the n power? In this case, it's minus 4x. Okay, did I do that right up there? Okay, good. I hope so. All right, we're on our way. Watch, now keep going. We're going to go, so we're going to write this as 5x times this series. And in here, I'm going to separate, this time I think I'll separate the minus 4 to the n and then x to the n. Okay, we're not done yet, because what we want to do, and they make us kind of do this, is we're going to take this 5x and move it in. But before I do that, I want you to see why it works, okay? So let's do this another way. Let's string out the terms. Let's write it as 5x. I'm looking up here right now. That's what we've got. So instead of writing the sigma notation, I'll go with the string out notation, if you will. So it's going to be 5x times 1 plus whatever squared plus dot, dot, dot. And this time we plugged in minus 4x. Now what would we do next? Well, typically we would distribute, wouldn't we? If we wanted to clean this up, and we do. And so it's going to be 5x. And then it's going to be like minus what? 5x minus 20x squared. Do you see that? Plus, that's 16 times, oh boy, that's going to be 80, I guess, x to the third. And then minus, yeah, you can see the terms, that, you know, they are what they are. But watch now what we do as I get rid of this. I'm going to move, I don't have much room here, but that same idea of distributing as we normally do in algebra can be taken care of in one fell swoop by bringing that 5x inside the sigma. Inside the sigma means he's multiplying here, 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 all the way across. He's distributing. And when we do that, we get a sigma answer, so to speak, a formula for it. And the way I'm going to write this, you see all this stuff in there? I'm going to clean it up. That's all I'm doing. I'm going to write 5, maybe minus 4x, 4 to the n, I should say. And what about the x power? What do you think? Yeah, it's one more, n plus 1. And so that one is done, okay? Okay, so this last one, I won't go through all those steps. What I'm going to do is just basically work on, oh yeah, and I'm going to do the interval of notation too, so this is going to take a little time. This last one, watch how fast you can be with this. You can just simply go, with me not talking much, you just go, okay, this one, okay, it's equal to x times 1 over 1 minus, oh, it's got a 6. What do we do with that 6? You ready? I need a 1 where the 6 is, so what should we do? How about we write x and factor the 6 out of the bottom? So we still have 1 minus there, do you see that? Okay, and when you distribute the 6, you get 6 back. But over here, if you take out 6, you algebra experts, what is that? Square root of x over 6. See that? So we're still getting it. We're still getting the form that we need in these homework problems. It's limited, but it teaches us a lot. So what we have is x over 6 times series, n is 0 to infinity. And this time it is being to the n power. What's being plugged in this time? This guy right there. It's radical x over 6, like so. And this time I'm just going to clean it up. That means to say I'm going to take this bad boy and bring him in as times x over 6. Okay. So we will get series n, 0 to wherever you want to go. In this case, cleaning this up, you look at the x's. Can you do the 6's, I should say? Yeah, that's 6 to the n, and one more is 6 to the n plus 1. And upstairs is, oh boy, can you do that? That's algebra. It's x to the 1/2 to the n times x to the 1. Can you? Yeah, it's n over 2 plus 1. It's x to the n over 2 plus 1 power. And this one is done. So we're building new series. And what I did on the first couple of them is I wrote out terms saying, look, we're still in reality. They are sums, and they're building these power series. This one I didn't do. I just said, I don't have to if I don't want to. If all you want is sigma, I'll just leave it alone. So you gain some confidence. Okay, last thing on this lengthy kind of recording is dealing with the interval of convergence. Now remember this part. This really finishes the problem off. Whatever you plug in, it has to have a magnitude less than 1. So let's do these one at a time. For the top series there, we have, if we just think of swinging this down, absolute whatever is less than 1. In each case, absolute whatever is less than 1. In each case, absolute whatever is less than 1. In the first case, what we plugged in was minus x squared. In the second case, it was minus 4x. And in the third, what was it? Yeah, square root of x over 6. You see, that creates this constraint on x as far as converging is concerned. In the first case, I can just melt away the minus because I'm in absolute value. But here's something that's tricky. If x is less than 1, then its square is even smaller. For instance, if I took 1/2 and I squared it, I get 1/4. It shrinks. But if I take something larger, like 1.1 and square it, I get 1.21. It gets bigger. So if x squared is between minus 1 and 1, that has to say also, and I'm not sure I'm convincing you, that absolute x itself has to be less than 1. Which means that x is between 1 and negative 1, and that's your new interval of convergence. You can check if you were to check the endpoints, you'd find that they don't converge. This one, again, melt away the negative, bookend it, and then divide by 4, and look at this guy. 1/4. This guy's interval of convergence shrunk, didn't it? Okay. Finally, this guy. All right, this is saying the square root of x over 6 is bookended. Now, the square root of x can't be negative. I noticed that now, so that's really going to, trim our sails a little bit. But if you multiply by 6, you get minus 6 less than square root of x less than 6. So what you could do is square both sides, right? But really, minus the square root of x, this is kind of tricky, I didn't notice this problem before, is going to always be greater than or equal to 0. It just is, okay? So when you square both sides, you get 0 less than, I'm going to worry about the less than or equal to, I'll get rid of that. And I get x, and over here, guess what? 36. And those are your intervals of convergence. So they change also. That's composition and intervals of convergence. We've got another video that's probably maybe shorter than this one by a bit, but thanks for listening. I hope this helps.